Hello friends, welcome to my channel. Let's have a look at problem 2344 together. Minimum deletions to make array divisible. So in this video, we're going to share some simple mathematical analysis, then share the shortcode. So this problem requires us to return the minimum number of deletions such that the smallest element in nums divides all the elements of nums divide. If this is not possible, return -1. So an integer x divides y if y modulo x equals 0. So here are two examples. So in example 1, if we delete all the appearances of 2, then the minimal element is 3, and 3 divides all the numbers in nums divide. So the output is 2. So let's also look at the constraints. So the length about nums and nums divide can be up to 10 to the power 5, which is a decent large number. So with that said, let's look at the method here. So the method is some elementary math. So here the thing that will be of use is a identity. So basically it says that for given n integers, let's call them a1, a2, and an. If their greatest common factor or divisor is d, then this d can be written as a linear combination of these numbers with integer coefficients c1, c2, and cn respectively. In other words, this is the form. So for the problem here, we could use the fact that a number y divides all the numbers a1 up to an is equivalent to the fact that y divides the greatest common divisor of a1 up to an. So the reasoning for this equivalence is very simple. So first, let's see one direction. If y divides the GCD d of all these n numbers, then y divides all the ai's because each ai is a multiple of d, right? So this is the one direction. For another direction, we just need to use the identity above. If y divides all the numbers a1 up to an, then y divides the linear combination of c1 times a1 plus c2 times a2 up to cn times an, so with integer coefficients, because d can be written as such a format, so y divides d. So that's about it for this equivalency. Next, we are going to specify our procedure. So with the equivalency realized, so the procedure is actually very straightforward. So we first compute the greatest common divisor of numbers in nums divide. Let's call it d. Then we count the number and frequency pairs in nums. And in the process, we are going to examine the key from small to large to see if it can divide d. If in the process we find a key which can divide d, then we are going to stop. And in between, we are going to increment the needed number of deletions using frequency information. So with that said, let's first write a format of solution and then dive a little bit deeper. So first, I'm going to get the GCD of numbers in nums divide. So here I can directly call this GCD function in math. So let's call it nums divide. So this star corresponding to pass this as a tuple to GCD function. So once we get this GCD information, then we can do a count for numbers. So let's call it count as collections counter nums. So this will give us the key and frequency pairs. And then we're going to sort the keys. So keys equals sorted count keys. And next we're going to prepare the return. We're going to initialize a variable called result. And then we iterate for the keys, for k in keys. So if k divides d, then we are done, right? Otherwise we increment the result. If k modulo d if d modulo k equals 0, then we're going to return the current result state. Otherwise, we're going to increment the result by the corresponding frequency. So that's it. So after the process, if nothing returned, we are going to return -1. So notice here, we should return -1 according to the requirement of the problem, not the final state of result. So with that said, let's do a check. It passes a special case, and then it passes the generic case. So in the first some tries, so we returned result, which is not correct. So with that said, I guess this is a format of solution. But it might be interesting for this problem to implement the GCD from scratch, so that we can understand this problem better. So now let me implement a GCD method. So I'll accept two integer numbers. So first I want n is greater than m. So if m is greater than n, so I'm going to interchange them. M and n equals n and m. Then we're going to check a special case. If m equals 0, then we're going to return n, right? So another case is if n modulo m equals 0, we're going to return m. So in other words, we're going to do a division with remainder, right? Div mode. So use n divided by m. And then we're going to make a recursive call, return self GCD and m and r. So that's the standard implementation of GCD. So then we can use another way to compute the GCD. So let me comment this part. Then first, I'm going to initialize the d to be nums 0, nums divide 0. And then we're going to iterate for y in nums divide. So you can start from the second or you can start from the first. It's okay. And essentially the point is that we need to consider a set, actually, a set of numbers. So repetitions does not produce new information. So for this problem here, let's just do it as this. Then we're going to reset the d to be self GCD d and y. And the final state will be the GCD we have computed using the math GCD function. So with that said, let's do a check again. It passes the special case, and then it passes the generic case. So let me write here. So for the d, you can also use math GCD, and nums it's already in here, in the above. So this is the choice 1. Let's see. So if you want to implement using the scratch, this is choice 2. So let's do a final check. Yeah, I guess that's about it for this problem. Thank you very much.